Lastly, we are on part 5, the solubility of silver salts. In test tube number 1, we have sodium chloride. In number 2, we have sodium bromide. And in test tube number 3, we have sodium iodide. I will add silver nitrate to each one and then shake them. As you see them left to right, they are labeled for you: sodium chloride, then sodium bromide, then sodium iodide. The chloride and bromide are clear, and the iodide has just a little bit of an orangish tinge to it. Now you should be able to see the different silver salts that were created. Sodium chloride, as we mix it and shake it, you can see that it's fairly white and chunky. And when we shake it, it has a tendency to settle to the bottom. Our next one is the sodium bromide. This one's probably a little bit harder for you to see, but it is a very pale yellow, almost like a butter yellow. And you can maybe see the chunks that have settled to the bottom. There, you can see the layer that has developed. And the last one, sodium iodide. Much more yellow color to it. Notice this one's not really settling out. Another thing that I would like for you to notice as we look at each of these, this is the sodium chloride. Notice the amount of layer that it has at the bottom, as compared to this is the sodium bromide. We see a little bit more of our solid, our precipitate. And then lastly, this is our sodium iodide. Notice that there's almost no settling, so it's fairly loaded with precipitate. It's just not settling out to the bottom. So these are our 3 silver salts. Color and approximate quantity of precipitate. You can see each of those and fill out the approximate quantity in those. Then we have the solubility of the ammonium solution. So I'm going to start adding ammonium hydroxide to each of the test tubes. And what you are watching for is to see how much of it dissolves and goes away. If, when I add a little bit of the dilute ammonium hydroxide or the ammonia solution, if it goes away, at that point it is considered to be soluble. If I have to add more to get it to dissolve and go away, then that's soluble and concentrated or slightly soluble. And then if it just doesn't seem to disappear, it's going to be considered insoluble. So I'll start out. Maybe you can see that that one has already turned the liquid part clear. So you can see that the majority of the liquid is clear, and we have a little bit of our solid left, but considering how much we started with, not a lot. There's our second one. Still have quite a bit of our solid left. It's not as clear in the liquid layer. And then our third one. We haven't lost anything. None of it has gone away. Okay, we'll add another dropper full. So starting with our sodium chloride. Sorry. You can see that almost all of our solid is gone. Then we move over to the sodium bromide. You can see it settling out. Still have quite a bit. And the sodium iodide, it's just not going anywhere. Sorry. All right, here we go, another dropper full. And voila, sodium chloride is all gone. The silver chloride has disappeared. So that one is going to be considered. Choices are soluble, slightly soluble, insoluble. All right, let's look at our sodium bromide. Let's see what happens now. Still dissolve. We're losing some, but not a lot. And lastly, our sodium iodide. We're just not losing hardly anything there. All right, we are going to speed up the process just a little bit. You can see it settling out. We still have some, but not very much as compared to what we started with. And then over here on our sodium iodide, we haven't lost any of our sodium iodide. So you can see the three progressions there. You have sodium chloride that is crystal clear now. We have sodium bromide in the middle one that we started with, and we've lost most of our precipitate. And lastly, we have sodium iodide, and we have not lost any of that precipitate. So write down your judgments as to whether they are soluble, slightly soluble, or completely insoluble.